All right, well, hello and welcome to this very special discussion about climate change here with the Kenosha Public Museums. My name is Nick Wiersum, and I am the Curator of Natural Science Education at the museums. And we are so happy to be joined today by Dr. Rachel Headley from UW Parkside. Dr. Headley is a geomorphologist and glacial geologist whose work focuses on how glaciers influence topography. Thank you so much for being with us today, Dr. Headley.
Hi, thanks for having me.
Great. Now, since we are celebrating Earth Day, we would love to ask some questions about an Earth Day topic that gets talked about a lot in the media and on the news. And that topic is climate change. And another word that goes along with climate change that we kind of still hear is global warming. So the first question I've got for you is, what is global warming and how is that different from climate change?
So in general, these terms are fairly interchangeable and generally understood to be the same thing. I'd say global warming is probably the older term, but climate change is more intentionally inclusive of different changes to the climate systems. So for example, while we know the world is warming and it's going to continue warming, just talking about that does not necessarily lead to a complete understanding of all the other changes. So some places are going to get drier, some places are going to get wetter. Biomes and ecological systems are shifting, storms and weather systems might be changing, as well as ocean currents. So using climate change emphasizes that the entire climate system is being impacted and not just the temperature. You might also see other terms that are sometimes used to describe the same thing, but are specifically used to emphasize that there are really negative impacts that might happen. And those are things like climate crisis or climate catastrophe.
Sure, great. Yeah, so basically it's global warming is one thing that's happening, but that's just sort of a part of climate change.
Yeah, it's just a piece of climate change, though generally when people say global warming, they mean climate change too. So
Sure. Absolutely. Yeah, and climate change is one of those things that we hear about a lot, and maybe like here in Wisconsin, it's like, oh, maybe it was a little warmer last summer, or maybe the snow came a little later than we sometimes expect this year. So how does climate change actually affect us right now?
yeah, so in Wisconsin in particular, the EPA has actually reported that the average temperature of Wisconsin has increased by about 2 degrees Fahrenheit over the past 100 years. If you're into gardening, you might have noticed that the planting zones have actually been shifting over the past decade. So more of Wisconsin is now considered zone 5 than it was in 1980. NOAA and a lot of other groups have measured the Great Lakes and have long measurements on these, and particularly Lake Michigan, since it extends further south, they've all experienced an increase in water temperature, as well as a decrease in the duration of snow cover. If you're into ice fishing, you might be able to recall changes from the past. There's other examples like the Berkey, which is a famous cross-country ski race in Wisconsin that's been going on since 1973. It was canceled in 2017 for the second time ever, where the first time was in 2000 due to lack of snow cover. Sawyer County, where that event's held, has actually warmed an average temperature of 3 degrees Fahrenheit in 1950 to an average temperature over 4.5 degrees Fahrenheit now. And there's been up to a 10% decrease in the number of days below 20 degrees Fahrenheit. There's a whole bunch of other areas that have experienced things too, like California or parts of Australia. They're experiencing bigger and more frequent fires, which have often made the news, particularly this past year. Some of the dangerous flooding that's recently taken place in the Midwest and the Great Plains is likely attributed to changing climates. Sea level rise is another big impact. It has large impacts on many major population centers, particularly in the Southeast US, like Florida or Louisiana. I actually do some research in Alaska, and some of the glaciers that I've done research on there have exhibited exceptional change due to the warming. There are pictures from only a decade ago that show many of the glaciers have retreated hundreds of feet from where they were like 10 years ago. The melt from these glaciers is filling rivers and streams faster and faster, and it's having a major impact on flooding and fishing in the area. And in another example, because there are so many, in Japan, they've actually been keeping records of the timing of the cherry blossoms since 1812 AD. And since 1800, the timing has been moving earlier and earlier in April, with this year, the peak blossom was the 26th of March of this year, and that's the earliest it has ever been since 1812.
Wow, yeah. So yeah, like you said, there's just so many examples of how climate change is actually affecting our planet like every single year. Um, and yeah, the change with glaciers, I think that's one thing that the glaciers particularly are something that people usually think about when they hear terms like global warming or climate change. It's like, oh, the glaciers are melting or the ice caps are getting smaller or
Yeah.
things like that. Now, here's kind of a tough question, and one that people who um, might not really understand climate change is, how do we know that climate change is actually real? It's actually happening.
Yeah, so this is a good question, and this is also something where we have lots of evidence for it. Particularly since it is a modern phenomenon, we have actual measurements over this era. We have thermometer measurements that date back to the 1700s. We have ocean level measurements and sea level measurements that date back even further back, because international trade and just shipping and boats have been important for a really long time to society. In terms of more human evidence, there are other kind of interesting examples like paintings of glaciers in the Alps from the 17 and 1800s, where the glaciers are much bigger than they are today if you go and like take a picture of it. There's written and oral records from around the world of shifting weather patterns. Even someone reminiscing about how, say, cross-country skiing used to be better in the past might be an indicator of climate, much like someone remembering fishing for abundant sturgeon in Lake Michigan in the past versus today might be an indicator of ecological change. So these types of records are important. We also have all sorts of natural records that can tell us about the changing climate. We have tree rings that can give us indication of changes in temperature and precipitation over decades to hundreds of years. Geologic evidence, like ice cores or sediment cores or lake cores, can tell us even further back how climate variables have changed over time. Ice cores in particular are one of our strongest pieces of evidence because they can go back thousands of years and include a lot of really important information in them.
Yeah, and we can actually like look at the gas like trapped in bubbles and things in ice too, can't we? And like just see how
Yeah, so
the atmosphere has changed.
yeah. So ice cores are really fantastic because as the glaciers form, they get bubbles of air trapped in the ice, and the bubbles retain the atmospheric gases of the time that they formed. So when we have ice cores from places like Antarctica or Greenland, where we can go back hundreds of thousands of years, we can actually look at the gases of that age and compare things like greenhouse gases like methane or carbon dioxide to modern measurements that we have of those gases and see how things have changed. And we have a very robust pattern, or not pattern, but we have very robust measurements over this period of time from multiple ice cores from both the Arctic and the Antarctic region that really corroborate that the modern climate change is something that's very different that we haven't seen before.
Sure, yeah. So it's not just, it's kind of that saying or that argument of like, well, the climate changes all the time, but it's like it's changing a lot more drastically now than it has naturally in the past.
Yes, yes. Yeah, we've certainly seen changes in the past, but in the past 800,000 years from these ice core records and these other records, things like carbon dioxide rarely got above 300 parts per million. And we are at, I believe, 419 today, which is, and it has been increasing. It's increased over 100 ppm since we've really had good measurements of it kind of in the modern era.
Wow. So are we sure that human activity is causing climate change, or the climate change that we're seeing now? And just how do we know that?
Yeah, so we are sure as scientists. So we can use past measurements of climate parameters that we can use to help us build our models that we use to understand the climate system. And this is one way that we can really test that hypothesis. So if we build these models that we know based on physical processes, we can include things like atmospheric gases, natural processes like volcanoes, changes in solar activity, all of these things. We can build these models, we can run them with only natural processes, and we can run them with natural processes and human activity in them. And when we run them with only natural processes, we don't see anything like what we actually see in our modern measurements of sea level rise or temperature or the amount of greenhouse gases in the atmosphere. And we've understood how greenhouse gases work for over 100 years now. It's older science from the 1800s that we have a pretty good handle on. We can also do things like make comparisons, like what you talked about, how fast it's changing, to changes in the past. So aside from working in Alaska, I also look at deposits of the North American ice sheet, the Laurentide. And this came down in North America, and it covered much of Wisconsin except for the driftless area. And particularly in southeast Wisconsin, we were covered by what's called the Lake Michigan lobe. And so this deposited a lot of material, and it retreated over 10,000 years ago. And the temperature was changing then, and it was actually enough to melt the ice sheet comparable, an ice sheet that's really comparable in size to Greenland and Antarctica now. There are some estimates that show that the peak rate of sea level rise due to the melt of the Laurentide ice sheet was similar to what we're seeing today, except today's rate is still increasing. That was the peak rate. And it's hard to specifically constrain like the exact temperature of Wisconsin from that time period. We can kind of get it within a range, but it took thousands of years for this glacier to leave Wisconsin. It caused major flooding over that long period of time, and even caused some rivers to switch flow direction. So if we saw these massive changes over a really long period of time, and we are seeing similar changes over a very short period of time, that is a good sense that something really different is happening. And when we couple that with our understanding from these models and how we can look at the actual greenhouse gases and measure what's actually coming out from our cars and our power plants in our industry, we can really tie this to human causes, that we are doing something very different than has ever been seen geologically.
Yeah, so kind of like on that point, like do scientists then all agree on what exactly is causing climate change?
Yes, they do. And climate scientists in particular, there's a number that's often cited that's 97% of scientists agree that climate change is caused by anthropogenic or human emissions. And this number actually comes from a variety of different places. So this is one of the biggest scientific consensus that exists. There are very few scientific ideas that have this many people agreeing with it. So there were a number of studies that looked at climate. So there have been a number of studies that have actually looked at the amount of climate-related papers. And one study found that in a survey of 4,000 climate-related papers, 97% of them endorsed humans causing climate change. And the other 3% either denied it or didn't mention a cause. So there have been a variety of other studies that have actually directly polled scientists to study climate. And generally, 97 to 98% of scientists have been found to endorse climate change strongly as being human caused. There's also been a really strong correlation with expertise. So in more expert scientists, so those who've been in the field for longest, those who have published the most papers and have the highest degrees, more likely to have PhDs and things like that, it's more like 100% endorse climate change than climate scientists.
Interesting. That's so the general consensus is like, yes, we're causing this, like our actions, our activities, human civilization is causing this rapid change to our climate. And I think one of the big reasons that one of the biggest contributors that we hear mentioned so often are things like fossil fuels, things where we're burning these fuels and releasing fumes into the atmosphere. So is it realistic to think that we might be able to stop having such a huge reliance on fossil fuels within our lifetimes?
Yeah.
Or do you think that that's something that's way far off?
I think it's not necessarily unrealistic to think of that. Renewable energy is really growing tremendously, and in many places, consumers and governments are actually pushing for even more. I know, for example, at Parkside, We Energy has recently built a huge solar field there, which wasn't there a couple of years before, and that's a big change. So many governments across the world are actually providing incentives to move away from fossil fuels through things like carbon taxes or carbon trading systems. And both of these systems have been used to control and eliminate other pollution, like CFCs that were leading to the hole in the ozone layer. So that was something that we took care of very quick. Technology can also change rapidly, so we might be getting better things in the future, but we also have some really excellent renewable technology already, like wind turbines, both onshore and offshore, solar panels, and they're really efficient and safe. And if we think about big changes over my own lifetime, I've seen the introduction of like bulky personal computers that maybe most people didn't have, to almost all of us walking around with our own smartphone that would blow away the 2-color monitor computer that my dad had set up in our basement when I was a kid. I got my first cell phone in high school in the late 90s, and less than a decade later, I had my first smartphone, and those were worlds apart from each other. So I think big technological shifts are possible, particularly when people actually want them and when people are pushing for them, and when there are pushes coming from both kind of the